Now, what about two different vectors? Can we understand what this says and how it relates to that? So let's say that I have two different vectors, A and B, and I want to try to understand what's going on. So my claim is that we are going to be able to understand the relation between this and that in terms of the law of cosines. So the law of cosines is something that tells you about the length of the third side in a triangle like this in terms of these two sides and the angle here. Okay, so the law of cosines, which hopefully you have seen before, says that, so let me give a name to this side. Let's call this side C, and as a vector, C is A minus B. It's minus B plus A. So it's getting a bit cluttered here. So the law of cosines says that the length of the third side in this triangle is equal to length A squared plus length B squared. Well, if I stopped here, that would be Pythagoras, but I don't have a right angle. So I have a third term, which is twice length A, length B, cosine theta. Okay? Has everyone seen this formula sometime? Yeah, no. I hear some yes, I hear some no's. Well, it's a fact about, I mean, you probably haven't seen it with vectors, but it's a fact about the side lengths in a triangle. And, well, I'm not sure that well, let's say if you haven't seen it before, then this is going to be a proof of the law of cosines, if you believe this. Otherwise, it's the other way around. So let's try to see how this relates to what I'm saying about the dot product. So I've been saying that length C squared, that's the same thing as C dot C. Okay? That we have checked. Now, C dot C, well, C is A minus B. So it's A minus B, dot product A minus B. What do we want to do in a situation like that? Well, we want to expand this into a sum of 4 terms. Are we allowed to do that? Well, you know, we have this dot product. It's a mysterious new operation. We don't really know. Well, the answer is yes, we can do it. You can check from this definition that it behaves in the usual way in terms of expanding, factoring, and so on. So I can write that as A dot A minus A dot B minus B dot A plus B dot B. Okay. So A dot A is length A squared. Let me jump ahead to the last term. B dot B is length B squared. And then these two terms, well, they're the same. You can check from the definition that A dot B or B dot A are the same thing. So there's no hidden trick here. This is really minus twice A dot B. Okay? So now let's compare these two formulas. Well, you see that this term is, I mean, this is the only difference between these two formulas for the length of C.